Hello everyone, Christopher here with McWane Science Center, and welcome back to SciSparks. They say what goes up must come down, but does it have to? What if we could turn gravity off, at least for a second or two? Well, on today's episode of SciSparks, defying gravity. Here, I have a powerful magnet, and here, a metal pipe. But here's the important part. This particular metal, not magnetic. And as long as it's not magnetic, we expect our magnet to fall straight through. And yet, that's not what happens. It might look like magic, but the truth is much more interesting. To understand what's going on, we first have to understand a thing or two about magnets. Every magnet has a magnetic field. Think of them like invisible circles connecting the North and South poles. When a magnetic field passes through a conductive ring, like our pipe or this copper coil, we get electricity. Electrons flowing around in circles we call eddy currents. On the flip side, electrical currents generate magnetic fields. Think back to our falling magnet. As it falls, its magnetic field generates a current around the metal pipe. That current generates a second magnetic field, which resists the first, slowing the magnet's fall. And we can take it a step further. Here I have a copper coil. When I press this button, a current flows around that coil, generating a magnetic field. That magnetic field generates a second current in this metal ring, which generates a second magnetic field resisting the first and... But here's the fun part. By making this ring super cold, we make its metal contract. As the metal contracts, it gets more conductive. That means a better current, and from a better current, we get a stronger magnetic field. But what does that look like? Let's find out. Here we go. In 3, 2, 1. Whoa! Talk about defying gravity. Well, that's another video in the bag. If you enjoyed this video, let us know by leaving us a like. And to catch new episodes as soon as they're released, don't forget to subscribe. Until next time.